All right, here we're solving an equation by factoring. If we look at problem number 1, it's already solved, or not already solved, it's already factored. So to figure out the solutions, we set each of its factors. That's the parts that are in the parentheses. We're going to set each of the factors equal to 0. 2x plus 3 equals 0, and x minus 4 equals 0. So we take these two factors and set them both equal to 0. Now let's figure out what's going to make it equal 0. I'm going to take away 3 on both sides. Let's see, 2x equals negative 3. I divide by 2, and I get x equals negative 3 halves, or negative 1.5. The other factor, we add 4 to both sides. X equals 4. So I would expect to have an x-intercept at 4. If I look at this on the graph, go over here to our graphing calculator and type this in. Let's see, that was 2x plus 3 and x minus 4. Okay, and we can see that the x-intercepts are, in fact, negative 1.5 and 4. So another way of looking at solutions to quadratics, it's points where the graph is going to cross the x-axis. In this case, it crossed at 4 and negative 1.5. Okay, let's look at another. How about number 5? Again, it's already factored for us, so we can simply take the two factors. The two factors, 8m, set equal to 0. And when I talk about factors, I'm saying the two things that are being multiplied. The two things that are being multiplied are the two factors. I'm going to set each one of those equal to 0 and solve. So let's see, we divide by 8 on both sides, so m equals 8 divided by, 0 divided by 8 is just 0. And the other factor, if we solve it, we add 2. So 7m equals 2. We divide by 7. So m equals 2/7. And so this one has x-intercepts at 0 and 2/7. Let's look at another. Let's try number 7. The first thing you always want to do is set it equal to 0. So I'm going to add 2 to both sides. Let's see, that leaves me 3b squared. Take away 12b equals 0. And when factoring, we always look for a GCF. Both terms are divisible by 3 and b. GCF, we take out a 3b, which leaves us b take away 4. And now I can see my two factors, 3b times b minus 4, and we'll set each of those equal to 0. And solve. Let's see, we divide by 3, so b equals 0. We add 4, so b equals 4. So this one I would expect it to go across the x-axis at 0 and at 4. Let's try another one. Let's try number 10. So first thing I'm going to do is take away 5. That gives me 4n squared plus 8n minus 192. So we set it equal to 0. Now we factor. Still looking for a GCF. I'm going to divide out the 4. N squared plus 2n. Let's see, what's 192 divided by 4? 192 divided 4 is 48. Okay, now I'm looking for two numbers that will multiply to give me negative 48 and add up to 2. 6 times 8 is 48, and they're 2 apart. The bigger one has to be positive since the 2 is positive. So let's see, I'm still working on number 10. So my GCF was 4, and we said that was n plus 8 and n minus 6. And then we look to see the factors, what's going to make them equal to 0. Well, the factors that have a variable. The 4 doesn't have a variable attached to it, so it's not considered part of the zeros or the thing that's going to make it equal 0. So in this next step, I'm going to ignore the 4 and look at the n plus 8 equals 0 and the n minus 6 equals 0. Solve each of these. Let's see, take away 8. So n equals negative 8. Add 6. N equals 6. So this one, the solutions to number 10, would be n equals negative 8 and positive 6. So the graph would go across at negative 8 and positive 6. If I were to go back and put this into the graphing calculator, the part that's set equal to 0, it's important that you set it equal to 0 first before you graph it. I should see that the graph goes across at negative 8 and at 6. Let's go back here and try that. So if I typed in 4x squared plus 8x minus 192, I should see the graph going across at negative 8 and positive 6, just like we found when factoring.